Please welcome to the stage, Eclipse with Charly Mwangi.
Wow, packed house. Super cool to be here. My name is Charly Mwangi. I'm with Eclipse Capital. It's super cool to be back in Michigan talking about reindustrialization. For a few of us, we started reindustrialization, and we've been doing this in America for the last 20 years or so. Eclipse started investing in industrialization 10 years ago. I started my career building manufacturing plants, and I've been doing this for the last 18 years before I joined Eclipse. I actually started my career as a stamping metals manufacturing engineer at Toyota about 20 years ago. Then I moved over to Nissan, was doing metals assembly. So metals has been a consistent thread in my career. And I just wanted to start with a quick story. Back in 2016, at Tesla, I was leading the body design, product design, metals assembly, a bunch of groups, all have to do with metals manufacturing. And interestingly, Elon challenged myself and my partner Greg Ryko early in 2016 to think about metals manufacturing assembly from a first principles. And the idea was to figure out what was the method that was most leveraged to reduce the amount of capital, the speed at which we launched the manufacturing facility, and reduce complexity. And we did this investigation and came up with two variables that are most leveraged in terms of reducing manufacturing complexity for metals. And those variables were, it has to be a manufacturing method that, one, reduces the content, and second, reduces the length of the value chain. And interestingly, in 2016, we concluded the most leveraged manufacturing method for metal, the most ideal, was actually 3D printing of metal. But the technology was not mature then, so we settled for metals casting. And by the way, a bunch of automotive companies have now copied Tesla, and they're doing the big castings. But what they don't know is that the conclusion was actually 3D printing was the most leveraged method to build metal products, like the body of a vehicle. The good news is Vulcan Forms has spent the last 8 years figuring out how to do metal castings at scale. And I'm super proud to introduce my former colleague, Kevin Kassekert, who is the CEO of Vulcan Forms. And Kevin has spent the last 20 years actually industrializing America, starting with building metal fabs for building semiconductor fabs, at Cypress. Then he went on and we worked together at Tesla, where he built battery vehicle manufacturing plants. And then most recently, he was at Redwood Material building factories for battery recycling and battery material manufacturing. And so he's taking that whole experience and bringing it to Vulcan Forms to enable 3D printing of metals at scale. So with that, I'd like to welcome Kevin to the stage.
All right, last but not least, good afternoon. I'm Kevin Kassekert. I'm the CEO of a company called Vulcan Forms. I want to tell you a little bit about what we're working on. So, common theme at Reindustrialize is understanding how do we start to bring manufacturing back to the United States. And it's no secret, metal products are everywhere. It's a $7 trillion a year industry, growing at about a 4 to 5% CAGR. So it's a massive opportunity. But the system is broken, right? How it's built today is dirty. It hasn't grown at the speed as maybe the Industrial Revolution would require. Most metal products are still made using outdated, globally fragmented processes. Facilities are oversized, inefficient, hard to coordinate. Supply chains are brittle. Cost to scale is massive. We went and mapped, you'll find this interesting, we went and mapped the metal atom, the distance a metal atom travels for one of our customers. And what we found was pretty astounding. And so if you think about the supply chain from a first principles perspective of the time a metal atom is mined out of the ground to the time it's delivered and implanted into a human being in an orthopedic implant product, we found that the metal atom was traveling about 20,000 miles throughout its life. And every time you touch it, it costs money and it adds environmental impact. And also, it's very expensive. The total logistics cost just in the end product is about 40 to 50% of just moving metal around the world. This is the same problem we had at Tesla when I was building the Gigafactory, and the same problem we were solving at Redwood Materials. And also now with tariffs and delays and customs, it really creates a lot of disruption in the overall supply chain. And so what we're doing at Vulcan Forms is revolutionizing that and consolidating the supply chain, innovating inside of that supply chain, taking out unnecessary steps, simplifying the process, and then scaling it massively. And all of those things, right, is how we are driving cost per kilogram of products down, of metal products down. And so what we do is we build advanced manufacturing factories. We design, engineer, and build much of the equipment inside of them, but only where we feel there's innovative opportunity. So we don't, if there is equipment available and technology available off the shelf, we'll work with partners on that, but we're seeing opportunities where it hasn't yet innovated and been disrupted. And so we're designing that. So we have designed and built our own additive manufacturing processes. And then we marry that with a whole host of other pre- and post-processing. This is a track record of scalable innovation. I've spent the last 25 years of my career building American manufacturing factories at Tesla, at Redwood Materials, previously at Cypress Semiconductor. That means scaling and standing up factories, deploying infrastructure, solving the hard problems behind the scenes with some of the most talented innovators in the world. And so what that looks like inside of that factory is we've developed a software suite where we can design for manufacturing and do a lot of virtual prototyping, and then we couple that with a raw materials supply chain that is more advanced and more efficient. And then we've developed in the additive manufacturing space the highest powered, most productive printing platform in the world. But that's not where it stops, right? We also have to do the subtractive piece. So to get to near net shape, the most efficient way to build a product is to only build the product that you need, as opposed to taking a giant chunk of metal and removing 90% of the metal through only subtractive processes. So we can prototype in a virtual space, so think of it as kind of measure twice, cut once. This is how we move fast without sacrificing precision. We adjust the design, we rerun the model, we keep going until it's right, and that allows us that first pass to make as good of a product on the first pass as we possibly can. So faster learning cycles, less trial and error, direct path to high volume production on a production-ready platform. What this ultimately means is we're starting to break that cost barrier. All right, so once the process is locked, we can scale it very quickly. And if you look at the chart here, this was assembled by a guy named John Barnes and the Barnes Global Advisors. John is a bit of kind of the godfather of additive manufacturing, if you will, and they went and looked at across all of the different ways to make a shape in a cost per kilogram basis. How do those track? And so, early days, laser powder bed fusion, early days 3D printing, right? It wasn't scalable, it wasn't fast, it wasn't efficient. But now, with technologies that are coming out, we're breaking that cost barrier, and it's starting to actually disrupt things like investment castings and machining and sand casting. And we're on this journey to drive this down even more significantly with kind of that full suite of manufacturing ecosystem. And so as you start to approach this, you start to disrupt the existing ways of making metal products, and you unlock all sorts of new design capabilities, things that can't be manufactured with traditional manufacturing, with subtractive manufacturing, things like rocket nozzles that have integrated cooling lines inside of the nozzle itself. We're doing quite well. Our platform isn't limited to one industry or one type of part. We work in defense and consumer and aerospace and medical and compute, anywhere where complex metal products are needed. Right? And so we have the ability to produce complex geometries at a competitive cost, and the opportunity is massive. Today, we're based out in Boston. We've got 2 factory locations. We've sold out our capacity, and we're installing and growing there. And then we're actively looking at our next generation factory, and so we're actively doing a site selection process now to figure out where that is. So this has been a very informative conference to understand what's happening in the industry and where we could potentially help. But we're doing this now, right? Not in 5 years, not later. We're growing right here in America right now. And with that, I want to thank you all for your time and appreciate it.